Okay, so last example. This is a problem very similar to the last question in your assignment. So if you're not sure what to do on that question, just, I guess, read this example again or watch this video again to give yourself a hand. So I've got three lines that enclose a triangle, or just three lines that I draw that make a triangle, and those three lines are described by the equations y equals -2, y equals -x plus 5, and y equals 2x plus 14. Okay, so let's graph these three lines just to get a picture of what our triangle looks like. Okay, so this first line here, y equals -2, that's a horizontal line at -2, and I'm just going to graph that in red. So here is that line. The next line is -x plus 5. I'm going to graph that in blue. So a slope of -1, y-intercept of +5. And since it's a negative slope, the line's going to be going like this. Okay, so since our slope is -1 and our y-intercept is 5, I'm going to go from the y-intercept and I'm going to go down 1. And the y-axis here you can see is scaled by 2, so half a unit is considered 1. The x-axis is scaled by 1, so a full unit to the right is 1 as well. So down 1, over 1, down 1, over 1, down 1, over 1, and so on. So I'm going to put a point there. Draw my line. There we go. And the green, that was blue. Let's do 2x plus 14 for green. So positive 14 is our y-intercept, and a slope of 2, and it's positive, so it's going to be going up and to the right like that. So I want to go down 2, left 1. So down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. So I'm going to put a point here as well and draw a line through those. There we go. So you can see this triangle that's been formed by those three lines. We need to find the area of that triangle. And you'll remember that area is equal to base times height over 2. The base of the triangle is the length or the distance between here and here. And it looks like this intersection is about -8, -2. And this intersection looks like it's 7, -2. But we can't be certain because I just drew this on an iPad with a stylus. So we're going to have to know those intersections for sure. And we can do that using a system of linear equations. Okay, so let's find the intersection between these two lines, the blue and the red. You'll remember that the blue line, sorry, that's green. The green line is 2x plus 14. The red line was just -2. So let's just set that system up really quick here. Y equals 2x plus 14. Y equals -2. Okay, so let's find the intersection between these two lines. We've already solved for y, so all we have to do is take that -2 in and put it in for that y there. So -2 equals 2x plus 14. Bring the 14 over and we get -2 minus 14 equals 2x. That gives -16 equals 2x, so x is -8. So this intersection is at the point -8, -2. So this intersection will be -8, -2. Let's find the intersection between blue and green. You'll remember blue was -x plus 5. Green was 2x plus 14. So let's do that calculation quick here. 2x plus 14, -x plus 5. So I substitute this expression for y for the other y here. That gives me negative x plus 5 equals 2x plus 14. And let's see, I'll bring the x over, bring the 14 over. That gives me negative 14 plus 5 equals 2x plus x. So that's 3x equals negative 9. Divide both sides by 3. X equals negative 3. So our point of intersection, oh wait, we need the y value. So y is, just using this equation here, negative 3, which is basically positive 3, plus 5 is 8. So the intersection at the top here is negative 3, 8. That's that point there. We got pretty close to that. And the last point of intersection is the line crossing, or the point of intersection between y equals negative 2 and y equals negative x plus 5. And again, to solve this, all we really have to do is put in this negative 2 for y here and solve for x. So bringing the 5 over, we get x is equal to 7. So this point's, again, we got pretty close, 7, negative 2. Now that we know the exact coordinates of those intersection points, we can find the actual base and the actual height of the triangle and then calculate its area. So you can see the x coordinates between this point and this point change from negative 8 to 7. How much of a distance is that? Well, that's just 8 here and 7 here, so it's a total of 15 for the base. And you'll remember the height of a triangle goes straight from the top straight down to the bottom. And the heights, because I know that it's exactly negative 2 here, because all the y values here are always negative 2, all the way up to a value of 8 for y. How much of a change is that? Well, that's 2, 4, 6, 8, 10. So the height is 10. Putting that into our area formula here, we get the area of the triangle is 10 times 15 over 2, which is 150 over 2, or 75. And since we don't know if this is in centimeters or meters or anything like that, we just write units squared.